In this lesson, you will learn how to use letters and symbols when writing equations from story problems. In the previous lesson, 4.13, we learned that the equal sign in an equation means that the items on one side of the equal sign are equivalent or equal in value to the items on the other side. We will use this same understanding to solve equations that include letters in the place of unknown values. Up until now, we have seen unknown values represented as squares, lines, question marks, and so forth. In this lesson, we will begin using letters instead. Let's look at this scenario. Barry ate 7 strawberries, and Jeremy ate some too. After they finished, the container of 15 strawberries was gone. How many strawberries did Jeremy eat? To understand this word problem, let's create an equation. We will reread the problem only a few words at a time. Barry ate 7 strawberries. This first part provides some information for our equation. We know the number of strawberries that Barry ate, 7. And Jeremy ate some too. We don't know how many strawberries Jeremy ate, but we know he ate some amount of them. We will represent this with the phrase Jeremy's strawberries. Now, after they finished, the container of 15 was gone. This means that the combined number of Barry's and Jeremy's strawberries was 15, or the equation 7, which is Barry's strawberries, plus Jeremy's strawberries equals 15. The information we do not know is the amount Jeremy ate. Instead of putting a box or a question mark or even his entire name, we can just use the letter J to represent the amount Jeremy ate. Our equation is now 7 plus J equals 15, which we can solve by remembering that the equal sign means each side is equivalent. 7 plus J is equivalent to 15. I know that 8 added to 7 has a value of 15, so I can replace the J with an 8 and check and see if my equation is balanced, or if both sides are now equivalent, which I can see they are. Here is our next scenario. For the 4th of July, Adrian ordered 50 balloons. 24 were red, 15 were blue, and the rest were white. How many balloons were white? Again, let's take it piece by piece. Adrian ordered 50 balloons. That's the total number of balloons, 50. 24 were red, 15 were blue. The rest were white. This is the value we do not know. I will represent it with the letter W. Our equation reads 50 equals 24 plus 15 plus W. To solve this, I will use a part-part-whole model. Using this model, I can easily visualize how the 3 different colors of balloons together make up the total number of balloons. I know that 24 plus 15 is 39, which means that the remaining 11 balloons are the white balloons. For our final example, Tiffany did 16 math problems on Monday and 3 pages of math on Tuesday. Each page had an equal number of problems. She did 40 problems in all. How many problems were on each page? Our equation would look like this: 16 problems plus 3 pages multiplied by p, which is the number of problems on each page, which is what we do not know, for a total of 40 problems, or 16 plus 3 multiplied by p equals 40. We can represent it in a part-part-whole model this way to help us see how to calculate the number of problems on each page. If we take away Monday's 16 problems from the total, we have 24 problems remaining that Tiffany did on Tuesday. We know these 24 problems were equally distributed on each of the 3 pages she did that day. Therefore, we can divide 24 by 3 to see that there are 8 problems on each page. Using letters to represent unknown values is helpful when creating equations from word problems. It provides us with a simple way to label a value as unknown while still being able to understand what that value represents. In this lesson, you learned how to use letters to represent unknown values in equations.